I just wanted to provide an update to what we've now termed as Canada's thermal corridor. Our energy harvesting started with our pathways to decarbonization. And really, we've looked at, and this is nothing that is unique to us, but we did a lot of work with the Heat Academy from Sweden and actually borrowed their model of a 3C pathway to decarbonization. And it starts with conservation, the first C. And in conservation, we look at reducing the demand for energy and using energy effectively and efficiently, followed by connect. And that's the integrated energy networks or the thermal networks, which is very important in the world of district energy and in the world of building heating. And then the last step is the conversion and eliminating the fossil fuel source, but really only done after the demand for fossil fuels has been reduced or eliminated as much as possible through the conservation and the connection efforts. And this is all driven around by this pie graph that shows in 2013 in Ontario that Ontarians wasted 66% of the energy they consumed, and they really only used 34%. So what it sets up for is that if you could lower your waste, you would need less, and that makes it much more affordable, and it also reduces emissions. So it's really a reduction in waste. It's the three R's. Makes it very important not only for our landfill operations or our garbage, but also very important for our heat and for our buildings. So we started off and we took that 3C approach and we looked at putting a project together that would look at how we could use the waste heat or the heat from industry in Hamilton. And of course, Hamilton has the steel makers and the industrial core, and there's a lot of energy intensity in those industries. And so what we see is a large resource that presently heat is just going to the atmosphere or going to the water. And we looked at how could we use that for building heating. And so our goal was to create a net zero energy utility to heat buildings with industrial residual heat. And we started off with identifying the opportunity through a study that the Hamilton Chamber of Commerce led and the Atmospheric Foundation funded. We then went into building a team and getting funding for the feasibility study, where we now are in, and leading to getting project funding, detailed design, and then a phased implementation. So this is the study that we're underway. It's been going on for about almost a year. It's about the value of the study is about $500,000. So it's a large study, and into it, what we've done is we've drawn several partners and people into it to help us make sure that we can be successful with this study. It's not necessarily a technology thing. It's more a culture and more working together, a community thing than anything else. And that's what what we've done is we put a big team together, gone across multi-functions, and it involves funding from the Atmospheric Foundation. It involves funding from the FCM, the Federation of Canadian Municipalities, through their GMF fund, the Hamilton Chamber of Commerce, Slate Asset Management, which is a large developer that's taking a brownfield from one of the old steel sites and moving to modernize it. ArcelorMittal Dofasco, AMD, one of the steel makers. The Port Authority of Hamilton, that's HOPA. Enbridge is working with us looking at distribution. The City of Hamilton, Air Liquide, who have a cryogenic oxygen plant in the port for the steelmakers. We're involving the Center for Climate Change Management at Mohawk College, McMaster Engineering, the Hamilton Industrial Environmental Association, New Horizon Development Group, Waterfront Shores, a development group. So we've got the whole gamut from the suppliers of the heat, from the industries to the developers, the users of the heat, as well as the distributors. And our engineers and consultants in this project are Rathco ENG as our technical side and Urban Equation on our commercial side. So what do we hope to accomplish with this thermal corridor and this harvesting of industrial waste heat? Well, we want to use waste heat as a renewable low carbon energy source. So decarbonization is a prime objective. We want to look at the integrated energy planning process, because one of the things that as we electrify heating and electrify buildings, we know that it's going to become there's more than just saying make it happen. There's more than just building new generation plants, but the transmission grids and the distribution grids for electricity are also going to have to be modified. And in old cities such as the Hamilton downtown, this is going to be a major effort, and it's going to be a major effort for the local distribution companies, and it's going to be costly. And all those costs will eventually find their way to either the taxpayer or the ratepayer. So it's very important that we look at an optimized solution to decarbonization of building heating. So again, this is reducing the use of high value electricity, reducing the use of high value gas for building heating. It works to retain, support, and grow local manufacturing as a pillar of Ontario's economy. So it's very much focused on industry, the consumers, and a distributor. One of the things we hope to achieve is affordability, both in the energy fuel or the costs of energy, and in breaking the linkage to fossil fuel, but also in limiting assets that need to be built and strengthened. The other thing, and this is just something that's been coming out in the last little bit, is I'm in Ottawa today for a conference with the National Building Decarbonization Forum for buildings. But the last time I was in Ottawa was about a month ago with the Canadian Nuclear Association. And I think everyone's well aware of the pickup in nuclear in Ontario and across the country, and looking at new nukes being built, but more than just the traditional large-scale reactors that you might find at Bruce and Pickering and Darlington, but looking at small modular reactors, the SMRs, and then even smaller, the micro modular reactors, the MMRs, which are in the 3 to 5 megawatt range, and provide not only electricity options, but they also provide heat options. Because the nuclear reactors that I've come to learn that the nuclear reactors are in the same mode. 66% of the energy that goes in is wasted as heat. And in order to move ahead, one of the things we need to do is reduce our waste. And that's a perfect key, or is a key to both Ontario and into the remote communities, is looking at these small nukes and how we could harvest heat as well as electricity to create green heat and green electricity. The project is segmented into 9 milestones, starting with just enough engineering to get the commercial side. So this study is very much a commercial and technical feasibility study. So the business side is as important as the technical side. And we started off with a bit of engineering. We moved to some commercial sides. Then we went back and did more engineering. And we're now presently in milestone 5, the business case. And in that, we're really looking at how do we make this work across the 3 levels of people. And so if we look at created the 3-legged stool, which is, I think we all see, that we all know of, and that in order for a 3-legged stool to be balanced, it has to have the 3 legs, and each leg has to be the same length. And what it means is that a successful project has to have consumers that are willing to purchase, suppliers that are willing to provide, and a distributor willing to invest to build and operate a thermal network. And that's the part we're in right now. Initial indications are that we will be able to come out with a business case that works for utilities. It'll be a long-term look at the business. And we're hoping to, within the next couple of months, be able to get past or to get into the business case in much more detail, and make a decision to go ahead with the later milestone steps, which is more engineering to define a better cost estimate, and then start to put together how would we finance and how we would actually build this project.